Dear students, welcome to the lecture series on the topic Engineering Graphics. So today we are going to discuss about projections of the oblique planes. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. So an oblique plane is the one which is inclined to both the reference planes, that is horizontal plane and the vertical plane. So let us work out the orientations of the pentagonal lamina with respect to these two planes. So we have a rectangular pentagonal lamina having h 25 millimeter. It has got one of its corners on the HP and the plane of the lamina is inclined at an angle of 45 degree to the horizontal plane. So it means that the first inclination of this lamina is with respect to the horizontal plane, and therefore we are going to assume to begin with that this lamina happens to be parallel to and contained by the horizontal plane. Why contained by? Because it has got one of its corners on the horizontal plane. So on the horizontal plane, in the top view, we are going to obtain the true shape of this pentagonal lamina below the XY line. And since this lamina happens to be perpendicular to the vertical plane, so in the front view, that is on the vertical plane, we will be obtaining the edge view of this lamina. Then in the second instance, the side of the lamina which is opposite to the corner which is lying on the horizontal plane, it is further inclined at an angle of 30 degree to the vertical plane. So this is the original side we are talking about. So the original side which is opposite to the corner, that is its true length is there, and it is inclined at an angle of 30 degree to the vertical plane. So the angle phi is equal to 30 degree. So we are required to draw the projections of the lamina. So once again, as usual, let us first of all evaluate these two locations or the positions of the lamina that we are going to draw below the XY line onto the horizontal plane. So if we draw the lamina, that is pentagonal lamina, into this orientation or the position, then you see whenever the lamina will be inclined at an angle of 45 degree to the horizontal plane, so the edge view which will be drawn onto the XY line, that is on the vertical plane, we can lift it this way or we can lift it this way. So either way around, whenever we lift the edge view of this lamina such that the surface of the lamina will be inclined with respect to the horizontal plane at an angle of 45 degree. So this will be resting on the corner. Over here also, if I lift it this way, this will also be resting on the corner. But all these edges, they will get reduced over here. So the apparent views will be available onto the horizontal plane in the top view. So there will be no edge which will be giving you the true length of this lamina which is opposite to this corner. So you see, opposite to this corner, this is the edge. Because the lamina is inclined, so this edge will get reduced. If I tilt the lamina this way, then this is the corner. The edge opposite to this corner will be appearing as the apparent length in the top view of the second iteration. So this position is discarded. So let us say if we draw it in this orientation, that is if the pentagon is drawn in this orientation, now what will happen? The top view will show the true shape of the line and the front view will reveal the edge view of the line. Now once this edge view is there, I am going to lift this edge view at an angle of 45, lifting from this corner. So I am going to lift this end or this edge. So the edge view of the pentagonal lamina will be lifted upwards through this particular corner over here. So what will happen? Now our lamina will be resting on the ground on the corner which is still there. It was already there in this case also, but still this particular edge will be parallel to the horizontal plane. So in the apparent shape which will be obtained thereafter after lifting this lamina at an angle of 45 degree, that is after inclination of this lamina at an angle of 45 degree to the horizontal plane, this edge will still be parallel to the horizontal plane, and we will be getting the true length of this edge, whereas this edge, this edge, this edge and this edge, all these four edges, they will be foreshortened or reduced. So this way, this is the correct shape or the orientation of the lamina which has to be drawn in the top view below the XY line. So that is why this is the correct orientation of the lamina and this one is the incorrect orientation or the position of the lamina. So let us draw the projections of the oblique lamina. So step 1, draw the XY line. Now since this lamina happens to be inclined to HP first of all, so to begin with we are going to assume that this lamina happens to be parallel to the horizontal plane. So since this lamina happens to be parallel to the horizontal plane, so in the top view we are going to get the true shape of this lamina. So the edge of the lamina happens to be 25 millimeter. So we have marked all these points in the top view, that is A, B, C, D and E. So this is the top view of the lamina which is drawn onto the horizontal plane and this will be drawn below the XY line. And this provides us with the true shape of the lamina. So this is our step number 1. Step number 2, we are going to draw the edge view of this lamina. So since one of the corners of this lamina is contained by the horizontal plane, so we will, once this lamina is parallel to HP, so this will be contained by HP. So just see, the projectors through A will be projected onto the vertical plane. Similarly, projectors through B and E, they will be projected on the vertical plane. And similarly, the projectors through C and D, they are also projected onto the vertical plane. So this gives us the front view of the lamina, and since this lamina is contained by the horizontal plane, so it is perpendicular to the vertical plane, and since this lamina happens to be perpendicular to the vertical plane, its projection onto the vertical plane will reveal the edge view of this particular lamina. Now we have to incline this lamina that in such a way that the surface of the lamina should be inclined at an angle of 45. So we could have inclined it this way or we could have inclined it this way. But if we incline the lamina this way, it will be resting on the horizontal plane on its edge, not on the corner. But we have been provided with this information that this regular pentagonal lamina has got one of its corners on the HP while the plane of the lamina is inclined at 45 degree to the HP. So inclination this way is discarded. So we have to incline this lamina by picking up this corner of the edge view. That is, we have to incline it this way so that it will be resting on the horizontal plane on one of its corners. So just see, we are going to draw one projector line through this, and this angle of inclination will be 45 degree, and as this edge view is rotated over here, so the markings A dash, B dash, E dash and C dash, D dash will have to be made onto this edge view which has been rotated. So straight away we are going to rotate this in such a way that the point A dash will appear onto the XY line, whereas this portion will be lifted at an angle of 45 degrees. So just see, this lamina surface is inclined at an angle of 45 degree and the orientation in such a way that we are going to mark these points over here. So A1 dash is marked here, B1 dash, E1 dash is marked here. We are going to measure this distance and mark it over here. Similarly, the total distance A1 dash to C1 dash and D1 dash will be located over here. Now having drawn these points, now the horizontal and the vertical projectors will be drawn to work out the corresponding view. So just see, the projector through A1 dash and the projector, horizontal projector through A will give us the point A1 in the top view. Similarly, the vertical projectors from B1 dash and E1 dash and the horizontal projectors through B and E will give us the points B1 and E1. And similarly, the vertical projector through C1 dash and D1 dash, and wherever it intersects with the horizontal projector of C, we get C1. Wherever this vertical projector intersects with the horizontal projector of D, we get the location of the point D1. And similarly, point E1 is also located. So having located all these points A1 to E1, now we can join them. So this is A1, B1, C1, D1 and E1. Now this is the apparent shape of this lamina when this lamina happens to be inclined with respect to HP at an angle of 45. Now there is one special characteristic about this apparent shape, that the edges A1 E1 is reduced, edge E1 D1 is reduced, edge A1 B1 is reduced, and the edge B1 C1 is reduced. Why? Because this lamina happens to be inclined to HP. But into this apparent shape we have got still one edge, which is C1 D1, and this edge, since it is parallel to the horizontal plane, so its projection on the horizontal plane, you can see this was the true shape. So we have got the same true length over here. So this is still the true length. That is why we have marked it as a true length. Now in the statement it is given to us, it's not given to us that the plan of the side of the pentagon which is opposite to the corner. We have been told that the side of the pentagon, this is the actual side of the pentagon which is still the true length. So side of the pentagon which is opposite to the corner which is lying on the HP. Just see, this is the corner which is lying on the HP, and this is the side or the edge of the hexagon which is just opposite to the corner. So this is the true length of this particular edge. So this true length is further inclined at an angle of 30 degree to the vertical plane. So we have to transfer this plan projection over here at an angle of 30 degree. So just see, 30 degree to the vertical plane. Now since we have to incline the true length, so this angle we have marked as angle phi. So after marking angle phi, once again rectilinear distances we are going to draw, that is 0.1, 0.2, 0.3, 0.4 and 0.5. So these 5 points we are going to mark over here onto this projection line. So just see, here we have got these 5 points. So this is 0.1, 0.2, 0.3, 0.4 and 0.5. Corresponding to 0.1 and 5, you measure this distance of B1 and E1. So just see, we have measured the distance of B1 and E1 over here, and corresponding to 0.2 and 4 there is 0 vertical distance, and corresponding to 0.3 measure the distance of A1 from this locus line. So we have measured this distance, and once you do so, you are going to get the rectilinear location of all these 5 points, which is quite easy now. So once you break this into rectilinear distances, it is very easy to transfer this plan projection onto this particular view number 5. So having obtained this view number 5, we have been able to obtain the plan of the oblique lamina which happens to be inclined with respect to HP at an angle of 45 degree and inclined to VP at an angle of 30 degree. Now we have to locate the front view. So we have got 5 points A2, B2, C2, D2 and D2 in the top view. So the vertical projectors through all these 5 points, we are going to bring them upwards. Similarly, the horizontal projectors through these points, that is A1 dash, B1 dash, C1 dash, D1 dash and D1 dash, they will be drawn, and the corresponding points of the intersection will be worked out in the front view. So just see, this is the projector for A2. Similarly, this is the projector for A1 dash. So we get the location of point A2 dash over here. Similarly, you have point B2 over here. Draw the vertical projector line through B2 and draw the horizontal projector line through the previous elevation view, that is B1 dash. So wherever these two intersect, you get the location of point B2 dash. Similarly for C point, so the vertical projector through C2 you can draw, and then from wherever this projector intersects with the horizontal projector which is drawn through C1 dash, will give you the location of C2 dash. Then you have the D2 projector. So the vertical projector through D2 you draw wherever it intersects with the horizontal projector which is coming from the D1 dash, that is previous elevation projection. So this will give you the location of D2 dash. And finally E2, just see E2 lies here. Draw the vertical projector through E2, and then wherever it intersects with the horizontal projector line drawn through E1 dash, so you get the location of E2 dash. So having located all these 5 points, so we can join A2 dash, B2 dash, C2 dash, D2 dash and D2 dash. So this is the elevation of the oblique lamina which happens to be inclined to both the reference planes. So with this we have been able to draw the front view. You see, this is the front view and the top view in 6 steps. So first step was the true shape, second step was the edge view, third step is the rotation or translation of the edge view, fourth step is your corresponding view, fifth step is your rotation of the fourth view, and the sixth step is once again the corresponding view. So with this we have been able to develop the projections of an oblique line, and this is the front view projection, and here you have the top view projections. So with this we have completed this problem. We will continue with this discussion in the next lecture as well. So thank you very much. Thanks a lot.